MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject Robotics Machine Vision System, unit number 5, Vision, Robotics Vision Systems. So in this chapter, last class we discussed about basics of digital image processing, then different morphology process. Okay, so in this chapter we are going to discuss about thinning. The thinning of a set A by a structured element B can be defined by terms of the hits and hits in miss transformation. The more useful expression for thinning asymmetrically is based on a sequence of structuring elements. Thinning continues. The process is to thin by one pass with B, then thin the result with one pass with B2, and so on until A is thinning with one pass with B. The entire process is repeated until no further changes occur. Each pass is performed using the equation. Thinning examples. Thickening is a morphological dual of thinning. So definition of thickening. As in thickening, thinning can be defined as a sequential operation. The structuring elements used for thickening have the same form as in thinning, but with all ones and zeros interchanged. A separate algorithm for thickening is often used in practice. So instead, the useful procedure is to thin the background of the set in his question and then complement the result. In other words, to thicken a set A, we form C is equal to A3, then thin C, then form CC. So this is one of the reason for using background thinning to accomplish thickening. Thickening examples. The notation of a skeleton of a set A initially defined, we deduce from this figure that if Z is a point of S of A and D of Z is the largest disk centered at Z and contained in A, the disk D touches the boundary of A at two or more different places. The skeleton of A is defined by term of erosion and opening. So these are the concepts. So skeleton examples. A can be also reconstructed from subsets by using the equations. So removing parasitic compound called pruning, complement to thickening and skeletoning by successive elimination, its endpoint. Then grayscale images, f of x comma y, the input image. Then you will change the value from the 0 to 255. That is, for example, the domain of gray values from 0 to 255, where 0 is black, 255 is white. So grayscale image, f of x comma y. So erosion of f by the flat structuring element B at any location is defined as the minimum value of the image in the region coincides with the B when the origin of B is at x comma y. The erosion of f by a non-flat structuring element is the grayscale example. So general effect of performing an erosion in grayscale images. If all elements of the structuring elements are positive, the output image tends to be darker than the input image. The effect of bright details in the input image that are smaller in area than the structuring element is reduced, with the degree of reduction being determined by the grayscale value surrounding by the bright details and by shape and the amplitude values of the structuring element itself. So dilation, this is the dilation grayscale. The dilation of f by a flat structuring element B at any location x comma y is defined as the maximum value of the image in the region outlined by B. So when the origin of is B at x comma y, the dilation of f by a non-flat structuring element. The general effects of performing dilation on a grayscale image is twofold. If all the values of the structuring elements are positive, then the output image tends to be brighter than the input. This is the example for dilation narration grayscale. Similar to binary image grayscale, erosion and dilation are dual with respect to the function complementation and the reflection. Opening and closing. In the opening of grayscale image, we remove small light details while relatively undistributed overall gray levels and larger bright features. So in the closing of grayscale image, we remove small dark details while relatively undistributed overall gray levels and large dark features. So opening GS picture is describable as for pushing object B under the scan line graph while transversing the graph according the curvature of B. This is opening and closing example. So some application of grayscale morphology, that is morphological smoothing, morphological gradient, top hat and bottom hat transformation, textural segmentation, granulometry. These are some examples. Granulometry is a field that deals principally with determining the size distribution of particles in an image. Because the particles are lighter than the background, we can use a morphological approach to determine size distribution. To construct at the end a histogram of it. So based on the idea that opening operations of particular size have the most effect on regions of the input image that contains particles of similar size. So this type of processing is useful for describing regions with a predominant particle like character. So this is an example of granulometry. So reconstruction concept. So let F and G denote the Markov and mask images respectively and the geodesic erosion of size 1 of F with respect to the G, where V denotes the point-wise maximum operator, the geodesic erosion of size N of F with respect to the G. So reconstruction by dilation of G by F. Opening by reconstruction of size N of image F. So closing by reconstruction of size N of an image F. Top hat by reconstruction, subtracting from the image opening by reconstruction. Okay, this is the concept we discussed. So in Unit 5, we discussed about uh, what is image. So how to represent the image in a digital format. So then what are the implementation, what are the applications like that we discussed, that is segmentations, edge detection, thresholding, then Windows techniques, then morphology concept like that we discussed. In morphology, we discussed about two type of concepts. One is binary morphology, and one is grayscale morphology. So main concepts of grayscale morphology, main application is with respect to the opening and closing, thickening and thinning. These are the main concept used in the grayscale image. Okay, thank you. We'll see you in the next class.